Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll understand what is gradient descent and we'll try to implement that using NumPy. Okay, so before we get started with gradient descent, let's understand what is calculus, the definition of calculus, and what is derivative with simple example. Okay, calculus is a mathematical concept. Okay, we have in differential calculus, integral calculus. So the whole idea behind the calculus part is identifying what will be the effect of a change in a specific variable, which is your independent variable. A change in independent variable, how it will be reflecting on dependent variable. So that's what is understood by calculus. Okay, that is the core concept. Okay, that we are trying to capture in calculus. And derivative is one of the way to do it. So derivatives measures the rate of change of a function, okay, with respect to its variables. Okay, so if I want to just orally say that, okay, f of x is equal to x square. Okay, if I do derivative of that particular function, okay, I get dy by dx is equal to, so in this case it will be f dash of x is equal to 2x. Now whatever the different values that I put for x, there will be corresponding change in terms of f of x. Okay, so that is the basic definition. And in machine learning, derivatives are used to determine the slope of the cost function. So you can think about linear regression, which is the most simple algorithm, okay, where you try to capture slope, which is em, which is dy by dx. Okay, you have linear points. Okay, you try to find the difference between two linear points, and in terms of both x and y, and give the slope. Okay, you update the slope. Now, if you want to talk about the example, in terms of example, you have y is equal to x square plus 2x plus 1, which is your quadratic equation. Okay, and you try to perform derivative on top of it. You get 2x plus 2 into 1 plus 0. So the derivative of 1 is 0 because it is a constant term and it doesn't contain any x. With respect to x, we don't have any x variable here. And derivative of 2x for x is 1, and it is totally turned into 2 into 1, which is 2. And the derivative of x square is 2x, so that's what we get here. And then at the end, what we find is dy by dx is equal to 2x plus 2. Now we'll use this function, okay, and try to understand how gradient descent looks like mathematically, right, in terms of code as well. Yeah. So what is gradient descent? It is an iterative optimization algorithm. So it is not like you just have one function, you apply certain values, you get the output. It's not like that. So it has to run iteratively until there is a certain condition that is satisfied. Okay. And for that we have to, there is some trials we have to do, which is the iterations, and we'll understand which is the minimum point for a particular function. In this case, if you see on the right hand side, this is the convex function. At the bottom, you will find the most minimum value for this particular convex function. And this function is represented by two parameters, which is theta 0 and theta 1, and j of theta is your cost function. Okay, so it is depending on these two parameters. Now, this gradient descent became popular because of neural networks and because of the back propagation which happens in neural network. Now, in neural network, it optimizes the objective function, which is the goal of the model training. Okay, your whatever the model you are trying to build, it is trying to learn something. For example, if you are building an image classification, okay, the objective function will be to understand the different properties of the images, and it should be embedded in your objective function. Okay, whatever is learned. Now that is learning part is done by your gradient descent. Now, by calculating derivatives, we take steps in direction of reduced error between the ground truth and the estimated target. So, the whole point of gradient descent is to find values for parameters like theta 0 and theta 1 such that you are able to reduce the amount of error present between the ground truth, which is the actual value, versus the predicted value. Okay, that's what the goal of derivative is. Okay. So now what we'll do is we'll understand how to implement this in NumPy. Okay, so let's jump to coding now. So first what I'll do is I'll import the package, which is NumPy as np, and then matplot. Okay, this is imported. So I have Copilot enabled, so it will be suggesting me the code which will be like happening, which will help me to write this code quite quickly. So let's define a function which is f of x. Okay, instead of this function I want to the function that we talked about, right, which is x square, yeah, x square plus 2x plus 1. Yeah, this is my function. And then I have df, which is my derivative of the function. Let me type in. So yeah, if you see here, we have f of x, which will take in x, and the returns is this convex function, which is x square plus 2x plus 1. And the derivative of this function, f of x, is this one, 2x plus 2. So let me run that. Now, first thing is, what is my initial value from where I am trying to reach to the minima? Okay, my initial value is x is equal to 5. Now, my learning rate is the step taken to reach, okay, the number of the way it has to reach the minima. Okay, we cannot take directly, we cannot jump from one value to other. So we are using learning rate to slowly move towards the minima value with the help of learning rate. So this is the learning rate, and then iterations is equal to, I'll call it about 100, and then my what I'll call is next x underscore values, okay, which is nothing but x. So why I'm creating this list is because I want to understand all the weight updates that is happening to x. I want to store it somewhere. Okay, so that's why weight updates are stored here. Updates are stored here. Okay, so now for so this is what I wanted to do, right? So if you see, so I have iterations here. Okay, so I'm iterating through like for 100 times, and during each iteration I'm updating x. This is my x. I'm updating this value x minus learning rate into the derivative for that specific value. Okay, I'll be passing 5 here first. It will be giving 10 plus 12 minus x minus variable learning rate into 12. Okay, which will be like 5 minus 1.2. Okay, this will be the first thing. If I just want to write it out for the first iteration, yeah, so this is the first value that will be coming up. Okay, next, whatever the value that we got here, we'll be storing it in x values. So that's that. Now what we'll do is we'll try to turn this x values from list into array. Okay, so we'll do that here. Now, so this is one part. Okay, let me run this cell. Okay, now I have this x values, right? Let me just show you what all these different values are present. So for 100 iterations, I started off with 5, and then it came to -1, which is the minima value for this specific function. Okay, this is the minimum value. So how do you know that, right? So if you apply this function -1 the whole square is equal to 1. Okay, let me just apply it here. -1. Okay, if I apply square, if I square it, it will be +1. Okay, and I have 2x, 2 into -1, again +1. This will turn into 0 because plus. Okay, this is minus, this is plus. Okay, so this is the thing, right? This is the minimum value. When my x is -1, the function turns into 0. 0 is the minimum value that is possible. Okay, now how it is happening, right? So this is what happened here. Like if you started off with 5 and then it came back to -1, when you pass that x value to your function f of x, okay, you get the minimum value 0. So let's understand it. Let's understand by plot. So first is I'll create an x range, okay, based on which I'll be plotting my curve. This is my x range, and corresponding y range, let's see, f of x range. Yeah, so this will be helping me doing that. Now this is done. Okay, let me just plot it. X range minus Y range. This is for the graph. Okay, let me add this. Okay, this is what I wanted to plot. Okay, we have it here. This is my convex function. Now I started off with x is equal to 5. Okay, and there is corresponding value of something 40 around, right? For this 5, we'll have some 40 some values. Now let's understand, right, how it will look like when you plot it like this. So first I'll be plotting all the x values that we got here, which is the weight updated x values, and then corresponding y values we'll get here and we'll plot it here. Okay, so that's that, and then I'll be just adding certain parameters here. Since my Copilot is giving nice suggestions, I'm just keep adding it. And plot dot x title is gradient descent, plot dot x label is x, and plot dot y label is f of x. Yeah, that's cool. Okay, so it has done most of my job. I don't have to do much. Okay, so first we are plotting this x range and y range, and then we are plotting the weight updates and its corresponding y value. So if you see here, okay, we started off with x is equal to 5 and corresponding value about 40. Okay, and every weight update, it led us to the minima value, which is -1. Okay, so let's understand that. So we have started off with 5, and then we slowly moved to -1, which is the minimum point for this specific convex function. Okay, so we have like what understood certain updates to your function. We were able to understand what is the minimum point for this specific function, which is x square plus 2x plus 1. Okay, so this is how, okay, in neural network as well, you will have some objective function, which is some quadratic or some other kind of a function, complex function, and it undergoes such iterations. Okay, there's like epochs in neural network. Okay, and you will be updating the weights and you will be finding the minima value such that the error between the estimated and the ground truth is minimum. Okay, so that's the end goal of gradient descent. So yeah, we have come to the end of the video. Okay, so I hope you understood what I was teaching, okay, in the last 5-10 minutes. And with this, I'll be concluding this video. Thank you for watching.